Hello Geometry, this is Miss Rich coming to you from home. We're going to go over some special right triangles in preparation for your Chapter 7 test. Okay, as you know, on a 45-45 or isosceles right triangle, the sides, whatever we have for the side lengths, the hypotenuse is going to be that number times root 2. Now you need to make sure you memorize this formula and know that sometimes you'll see the 45-degree angle. Sometimes you'll see the slash marks saying that's isosceles, and of course this is on a right triangle only. And then sometimes you'll see a square, and if you have a square, it is always made up of two 45-45 right triangles, so you can use this same formula. So if you're given this side, it's very easy. If this is 4, you have 4, 4, 4 root 2. If it's 10, 10, 10, 10 root 2. If it's 100, 100, 100, 100 root 2. If it's 1036.1, you have 1036.1, 1036.1, and 1036.1 root 2. So it's particularly easy when you're given one of the two equal sides. Not as easy when you are given the hypotenuse. So if we look down on this problem, now if you want to write all these problems down and pause the video and try them and see if you get them right, that might be a good idea. But we'll do them together here. If this is 10 root 2, know that that's your x root 2 side. Therefore, if we solve this equation, these sides are 10 and 10. Now our goal here is to find all the side lengths on the triangle. Now the harder kind is when you're given the root 2 side and it doesn't have a root 2 with it. So remember, always write down your formula, x root 2, and set that equal to the side you're given. X root 2 equals 8. So this is just an algebraic equation we're trying to solve for x. So to solve for x, when you have x times root 2, is of course to divide both sides by root 2. So x is equal to 8 over root 2. But as we know, can't have a root on the bottom. So we rationalize by root 2. 8 times root 2 is 8 root 2. Root 2 times root 2 is the square root of 4, or 2. And we can simplify that. Don't simplify into a root from out of a root, but we can simplify the 8 over 2 to 4 root 2. Now when you solve that, think about what have you found. A lot of people want to tell me, well, I've just found the hypotenuse. No, the hypotenuse was 8. We just found x, and x are the two equal legs on the isosceles right triangle. So those are equal to 4 root 2. Okay, next problem. Here we have, notice this one doesn't have the equal sides, so sometimes you don't have the equal sides marked, but of course we know in an isosceles right triangle that those would be equal. Write in your formula, this equals x, this is going to be x, so of course that's root 3 as well, and this is going to be x times root 2. Well, if x is root 3 times root 2, gives you that this side is root 6. Again, think about what you're solving for. We just found the hypotenuse. Now the last one here is if you're given a square, and sometimes these are given in a word problem. You'll be told you have a square with a diagonal of 5. So know that a square is just two isosceles right triangles. So on each of those right triangles, your formula is x, and x root 2. So again, when you're given that x root 2 side, set it equal to 5. Solve for x by dividing by root 2. So x equals 5 root 2. But of course we have to rationalize. And we end up with 5 root 2 over 2. Now see if you can simplify the fraction, but of course we cannot simplify 5 over 2. So what have we just found? We have found all 4 sides of the square, or 5 root 2 over 2. Sometimes you'll be asked on this problem to find the perimeter of the square. The perimeter of that square would of course equal 4 sides times 5 root 2 over 2. Just a little arithmetic here. That 4 and that 2 will cancel. So you have 5 times the 2 is 10. Don't multiply into a root, so your perimeter is 10 root 2 if you need all 4 sides added up together. Okay, so now our next triangle was our 30, 60, 90 triangle. And on our 30, 60, 90 triangle, our formula is x root 3, and 2x. Now pay attention that the 30 degree should always be across from the shorter leg. Now, I must admit, I don't always draw those to scale, so make sure your x side is across from your 30, your x root 3 side is across from your 60, and your 2x is your hypotenuse. So make sure you memorize that. It makes sense that your 2x is your longer side. 2 is larger than square root of 3. 2 square root of 4, so of course x root 3 will be a smaller side, so don't put that on the hypotenuse. It's also good to remember the root 3 is on the triangle with the 30. The root 2 is on the triangle with the 2 equal sides, so don't get the root 3 and the root 2 mixed up. So remember, you use this a lot when you have an equilateral triangle, because an equilateral triangle has, of course, 60-degree angles, and then when you put an altitude in the middle, you have two 30, 60, 90 triangles. So whenever you see equilateral, know that you're going to use this formula as well. So once again, the easiest kind is when you're given the smaller side, the small side across from the 30. That's your x. Write in your formula across from the 60 would be x root 3. Hypotenuse would be 2x. So if x is 5, 2x is 10. X root 3, 5 is x times root 3. Would be that side. Pause the video and see if you can do the rest of these problems, and then come back and see if you've gotten them right. Number 2. Write in our formula. Here's our 30. So across from our 30 is x. Across from the 60, x root 3. Hypotenuse is 2x. Set that equal to what we're given. So if 2x is 24, x would be 12. And here is my x side. And across from the 60 would be x root 3, 12 root 3. Awesome. Keep on going here. Okay, now this is the hardest kind, is when we're given the side across from 60, the longer leg. Write in our formula. Across from the 30 is x. Hypotenuse is 2x. Across from the 60 is x root 3. So again, we've got the root 3 side, and it doesn't have a root 3 beside it, so we just need to solve that algebraic expression. X root 3 is equal to 12, and we're trying to solve for x. So we divide by root 3. X equals 12 over root 3. Can't have a root on the bottom, so we rationalize by root 3. 12 times root 3 is 12 root 3. Root 3 times root 3 is 3. So there's our x again, but here we can simplify this 12 over 3 because everything's connected by multiplication and division there, which gives us 4 root 3. Now what did we just find? All that work and we're not sure what we just found? We found x, and x is the side across from the 30, so that's 4 root 3. Make sure you find 2x. 2x, if we double 4 root 3, we do 2 times 4, 8 root 3. Don't double the root 3. You're already doubling it by multiplying the 2 on the outside. Don't multiply the 2 into the inside. So there are your answers for that one. Okay, next problem, number 4. Again, we have the side across from the 60. So the 30, there's our x. This is equal to x root 3. And this is equal to 2x. So hopefully you're starting to notice that when you divide by root 3 and rationalize, every time you're dividing by 3 and multiplying by root 3. So the shortcut, if I divide 10 by 3 and multiply by root 3, I know this is going to be 10 root 3 over 3. So if you see that shortcut, go ahead and use it on the isosceles right triangle. If you divide by root 2, you're dividing by 2 and multiplying by root 2 once you rationalize. So if we double that, we only double that top number. So for 2x, we get 20 root 3 over Move it on. Okay, now our side across from the 30 is the square root of 6. So that is x. Across from 60, we have x root 3. Hypotenuse is 2 times x. So if we want to do x times root 3, that would be x root 6 times root 3, which would be root 18. And we can kind of simplify these as you go. 6 is 3 times 2, so if you want to go ahead and think of that in your factors, 3 times 2 times 3, and we're going to pull out a 3 from my square root of 18, and we have 3 root 2 as the simplified answer. Now what did we just find? We found the x root 3 side, which is over here. So this is 3 root 2, so don't let that throw you off that the root 3 side has a root 2 beside it, but it does. So if we double x, make sure you're doubling x to get 2x, you get 2 times root 6. 2 times root 6, 3 times root 2. Okay, and then the last one here, equilateral triangle with an altitude of 18. So this is 18. Equilateral triangle, again, means that these angles are 60. All three sides are equal. The top angles are 30. So using my formula, across from the 30 is x, hypotenuse is 2x, the altitude is across from the 60, so the altitude is always going to be my x root 3 side. So my x root 3 is equal to 18. So I'm going to divide by this and rationalize, but again, the quick way, every time we rationalize by root 3, we divide by 3 and multiply by root 3. So 18 divided by 3 is 6, and stick a root 3 next to it. That is my x. That is this half of a side, 6 root 3. So 2x, the whole side of the triangle, would be 2 times 6 root 3, which is 12 root 3. Now again, often you're asked for the perimeter of a whole equilateral given an altitude. So we'll move down here. If our side of each side of the triangle was 12 root 3, if we want the perimeter of a triangle with 3 equal sides, we'd have 3 times the side. And if each side is 12 root 3, we'd end up with 36 root 3. So know how to find the perimeter of squares and equilaterals given the diagonals or altitudes as well. All right, we are going to stop there.